All right, we are going to review for our electricity and magnetism test today. We're going to do so with this paper that says electricity and magnetism at the top. You should get a paper copy. If you haven't already, you can get one and then go back to this video and look at it. Or you can print off the one that is on Google Classroom and fill it out there. Either way, this is a great way to review for your test. Resistance is measured in a unit called, well, we know that volts measures voltage. In our triangle, remember, voltage goes on top, current goes on the bottom left, and resistance goes here. Resistance is measured in ohms, voltage is measured in volts, and current is measured in amps. So the unit for resistance is the ohm. Now, which statement, or the statement that current is equal to voltage divided by resistance, is known as Ohm's law? That's the equation we just had right there. A path that allows only one route. If you see just one route for current to flow, that is a series circuit. Parallel has more than one path. Electric charge that has accumulated or built up on an object is referred to as static electricity. Protons are positive. Electrons are negative. And neutrons are neutral. A circuit that has two or more branches for electrons to follow, so not just one, two, would be a parallel circuit. Current that does not reverse direction. So alternating is where it reverses back and forth. Direct comes from a battery, and that goes in one direction. So batteries produce direct currents, and generators produce alternating current. Because remember that electromagnet, the generator spins back and forth. So current that does not reverse comes from a battery and is direct. The location of the strongest magnetic forces are at the poles, either in North or South Pole. Current that reverses direction in a regular pattern, like what we just talked about up here, is alternating and comes from a generator. Current is measured in units called, well, if we look up at number 1, current is measured in amperes or amps. So it would be amperes. The region around the magnet where the magnetic forces act would be the magnetic field. Objects that keep their magnetic properties for a long time are permanent magnets. Temporary magnets are like electromagnets that you can make and attach to a current to become magnetized, but they are not always going to be magnetized. So permanent magnets keep their magnetic properties. The function of an electric motor, remember, motors start with a battery. So a battery is going to provide electrical energy to make the car move. So it'd be electrical to mechanical. If you remember, electrical energy comes from the battery. I know that chemical energy is converted to electrical energy in a battery, but we're talking about a motor, not a battery. So a motor converts electrical energy into mechanical energy. A generator is going to take mechanical energy, like from a hand crank. So generator starts with mechanical energy and then ends with electrical. So you can, like a hand crank flashlight, that would be something similar to a generator. Okay, so we're going to flip to the back and we are going to look at the top. It says, what kind of circuit is this? Well, I notice that there is only one path for the electrons to flow. And if there's only one path, that makes it a series circuit. A battery, since it has two ends and electrons flow from one end and into the other, is going to produce a direct current. The battery is not spinning or reversing, so it's not an alternating current. The magnetic force of a magnet is not the same everywhere. It's strongest at the poles. Voltage is measured in volts. Look back to number 1 if you're confused on that. And magnetic field lines. I want you to cross this one out. We did have it on the notes, and I can show you that. Let me show you that really quickly. Magnetic field lines. Where are we at? Right here. So magnets have two poles. At either end, they have the magnetic fields. The magnetic field lines around a horseshoe and disc magnets are closest together at the poles. So you can notice these lines are closest together at the poles. So when we look at this question right here, and it says they always travel in this direction, don't worry about that so much, because there's a couple answers here that could be correct, and there's not one correct answer, but for our purposes, we don't need this question. So cross this question out. All right, what type of circuit is this? Well, I see multiple pathways. 1, 2. So since there's multiple pathways, it's going to be parallel. What is the charge of an electron? That is going to be negative. A material through which electrons don't flow easily. Remember, if they do flow easily, it's a conductor. If they don't, it's an insulator. Lightning is not harmless. It's not a buildup of neutrons. So, is it a high voltage electric current or a large discharge of static electricity? We're going to say it is a high voltage electric current. Okay, I went back and looked, and I actually want to change this answer right here. So lightning is a strong bolt of electricity, but it's a result of a large discharge of static electricity. During a storm, we have a large buildup of negative electrons, and then at one point, it will come down to Earth and discharge and ground itself. Okay, so let's change that to letter D. Now, we flip to the back of this page. Monica has a string of lights on a parallel circuit. What will occur if one of the light bulbs on the circuit burns out? If it's parallel, nothing will happen to the rest of the bulbs. If a bulb is added to the one below, if we added another bulb right here, that means less current is going to the other three. So the other bulbs will glow with lesser intensity. It's a cold day. You remove your snow hat and your hair stands up. Why does it do that? Well, the hair is going to gain electrons, that's for sure, become negatively charged, that's correct, and attract the other hairs on your head, no. Gonna gain electrons, yes. Become positively charged, no. So it's not going to attract. This says each hair loses electrons, becomes positively charged, and repels the other hairs on your heads. So let's think about this one for a second. So if we look at this slide right here, it says as electrons collect on an object, it becomes negatively charged. As electrons leave an object, it attains a positive charge. We know opposite charges attract and like charges repel. So if we were talking about static, making things like clothes out of the dryer stick together, that would be the fact there were lots of, it says some of the clothes have gained electrons by rubbing against other clothes. The clothes losing electrons become positive and they are attracted, sticking together. But in the case of your hair sticking up, like this right here, what happens is there is a buildup of negative electrons. They repel each other and your hair stands up. So on this page right here, what we need to do is we need to change the ones that are incorrect to make it correct. So let's just say it's B. Okay, I don't want you to circle any one answer. I want you to change an answer to make it correct. So the hair is going to gain electrons. It's going to become negatively charged, and it's going to repel other hairs on your head. So if I was going to change this one, it would be correct. You could also choose this one. Hair gains electrons, becomes negatively charged, and repels. Okay? So whichever one you choose, be sure you change it to make it the correct answer. All right, find the resistance in a circuit that draws 0.25 amps with 12 volts. In our triangle, we know that voltage goes on top, 12 divided by 0.25. Do that math in your head or in your calculator and get your resistance. All right, the next one, we have a 27 volt, so 27 goes on top. 125 ohms. You're going to divide those two and get your current in amps. And then at the bottom, we have 3.5 amps and 1500 ohms. We take those two numbers and multiply them together, all right, to get your voltage in volts.